Spontaneity. A spontaneous process is one that occurs by itself without outside intervention. Processes that require energy input are non-spontaneous. Spontaneous reaction is one which occurs immediately when contact is made between the reactants. So, spontaneity means having the potential to proceed without the assistance of external agency. However, it does not tell about the rate of the reaction or process. Spontaneous reaction or process cannot reverse their direction on their own. In case of spontaneous reaction between hydrogen and oxygen, we find there is a decrease in enthalpy. H2 gas plus 1/2 O2 gas give H2O liquid. Delta R H theta is equal to minus 285.8 kilojoule per mole. However, spontaneous reaction between graphite and sulfur is endothermic. C graphite S plus 2S liquid give CS2 liquid. Delta R H theta is equal to plus 128.5 kilojoule per mole. Decomposition of mercuric oxide is an endothermic reaction which is spontaneous. 2HgO solid gives 2Hg liquid plus O2 gas. Delta R H theta is equal to plus 90.3 kilojoule per mole. When two gases diffuse into each other in a closed container which is isolated from the surroundings, we find that delta H is equal to 0. That is, there is no change in enthalpy, but still the process is spontaneous. We conclude that negative value of delta H is not the only criterion of spontaneity. Entropy and spontaneity. Since spontaneity cannot be explained on the basis of only enthalpy change, therefore, we now introduce another thermodynamic function, entropy, denoted as S. Entropy is a measure of the degree of randomness or disorder in the system. The greater the disorder in an isolated system, the higher is the entropy. For a given substance, the crystalline solid state has the lowest entropy, most ordered. The gaseous state shows highest entropy. Entropy, like other thermodynamic properties such as internal energy U and enthalpy H, is a state function, and delta S is independent of path. A system at higher temperature has greater randomness in it than one at lower temperature. Heat added to a system at lower temperature causes greater randomness than when the same quantity of heat is added to it at higher temperature. This implies that the entropy change is inversely proportional to the temperature. For a reversible reaction, delta S is related with Q and T as delta S is equal to Q reversible upon T. The total entropy change, delta S total for the system and surroundings of a spontaneous process, is given by delta S total is equal to delta S system plus delta S surrounding greater than 0. The entropy is maximum when a system is in equilibrium, and the change in entropy delta S is equal to 0. Change in entropy of a reversible process, delta S system is equal to Q system reversible by T. Gibbs energy and spontaneity. We have observed that for a system, total entropy change delta S total decides the spontaneity of the process. We find for most of the chemical reactions, there are both enthalpy change and entropy change. It is clear that neither decrease in enthalpy nor increase in entropy alone can determine the direction of spontaneous change for the systems. We therefore now introduce another thermodynamic function, the Gibbs energy or Gibbs function G, as G is equal to H minus Ts. Gibbs function G is an extensive property and a state function. The change in Gibbs energy for the system delta G system can be written as delta G system is equal to delta H system minus T delta S system minus S system delta T. At constant temperature, delta T is equal to 0. We have delta G system is equal to delta H system minus T delta S system. Dropping subscript system, we get delta G is equal to delta H minus T delta S. Delta G provides condition for spontaneity at constant pressure and temperature. 1. If delta G is negative, less than 0, the process is spontaneous. Chemical reaction proceeds spontaneously in the forward direction. 2. If delta G is positive, greater than 0, the process is non-spontaneous. The process proceeds spontaneously in reverse.